Awesome. So hi, Rosie Riveters. I'm super excited to be with you all today. I hope that over the past 4 weeks, you've had a great time learning, experimenting, getting things wrong, getting messy, making everything from art bots to edible water bottles and everything in between, and learning about binary code. You all had a fun time? Yeah, awesome. Well, I couldn't be more excited today because one of the things that we get to do with our Rose Riveters is introduce you to real people in STEM, science, technology, engineering, and math. And we call them our STEM role models. And we have a very exciting role model today with Dr. Ochoa here to talk to all of us. I have been calling it Ochoa Day for like the past 2 months, so I'm really excited. So I know that you all are as well. You all got to talk a bit about and read a bit about her biography in your last class, and I know you have some questions, and there might be other questions that come up from hearing her story and presentation to share with us. So after Dr. Ochoa talks to us a bit about her experiences, we'll have time for Q&A from that. Dr. Ochoa, I could talk all day, but really that's not why we're here. So I'd love to just hand the floor over to you. And in front of you today, you have kids ranging from the ages of 5 all the way to 14, many from military connected families, as well as our instructors who are also military connected. We are in the Family Readiness Center at Joint Base Andrews. And so all of us have been coming for the past couple of weeks and exploring STEM together, and we couldn't be more excited to talk to you. So I'm going to give over the proverbial floor or the Zoom screen and let you take it away.
Okay, well, thank you. I'm very glad to be with you this morning, and welcome to everybody. I wonder how many of you know that we have 7 people in space right now on the International Space Station. 3 of them are NASA astronauts, and 2 of them are women, Jessica Watkins from NASA and Samantha Cristoforetti from Italy. Jessica is a geologist who studied landslides on both the Earth and on Mars. We've had people in space continuously for over 20 years now. So, much longer than the time that any of you have been alive. Crew members generally stay about 6 months in space or so, and then a new crew arrives to switch out with them. NASA is also working on developing a powerful new rocket and a spacecraft that will take astronauts to the moon in just a few years and eventually to Mars. And the first launch of that new rocket and spacecraft, but without astronauts on board, is going to happen later this year. It's called Artemis 1 launch. So something you might look for possibly in the fall. So NASA has a terrifically talented group of people who make this all happen. Engineers, scientists, astronauts, and many other professionals who work together to accomplish this. And how did they all get to work at NASA? Well, there's many paths to get to NASA, but I thought I'd talk a little bit about my own path. When I was around the age of a lot of you, the US had embarked on the incredible task of landing a man on the moon. And it was achieved when I was 11 years old. Many of my astronaut colleagues decided upon technical careers at an early age because of that, because they wanted to become astronauts when they grew up. But it wasn't something I ever dreamed I could do. And part of the reason was all astronauts were men at the time and remained so until I was about halfway through college. But looking back, I did some smart things in high school that eventually helped prepare me. I took math every year, including calculus in my senior year, so I could begin to understand how math is used in science and engineering. I took English every year. No matter what field you end up in, your reading, writing, and speaking skills are generally important in how well you do and how far you advance. And if any of you are bilingual, that's an even greater advantage. And then I also pursued interests outside the classroom, and my main interest was music. I started to play the flute when I was 10 and played all the way through school, and actually still play today. And I even got to play my flute in space. And it's interesting that most astronauts do have some interests like that, maybe music, athletics, art, or something else. couple of things that I should have done but didn't do. I really didn't take very much science in high school. I only took biology, and later on I wished I had taken chemistry and physics. So I ended up doing that in college. But what I found out was, your interest can change. I didn't think I was interested in science, but it turned out that I certainly developed an interest in it. And also today, the world is more and more geared to uses of technology. So in any field, or even just for general everyday use, it's really helpful to have some idea of how this all works, whether or not you're going to be working directly in developing new products or doing science research. So I think the more opportunities you take advantage of in high school, the more options you'll have for your future. So fortunately, because I did take a lot of math, when I went off to college, I continued that, and that's what really got me interested in science. And I ended up majoring in physics, which is the science that studies energy, light, motion, gravity, really all the things that happen around you and that really power sort of all the equipment and tools that you use in everyday life. And I had a chance to do some research to really start to understand how you learn new things about science, and ended up not only graduating from college, but going on to graduate school. And when I was in graduate school is when the first space shuttle flew. For the very first time, a very new kind of spacecraft that could do science experiments in space. A couple years later, Sally Ride flew in space. She was the first American woman to fly in space. And it was really when I saw her flight and realized she had been a physics major and had gone to the same school I was currently at, that I got the idea of maybe that was something that I could do, where I could, join my interests in human spaceflight as well as in science experiments, and be able to do experiments that you could only do in space. And that's what really got me interested in NASA. The ability to discover new knowledge, work in an environment that's so different than the environment that we have here on Earth. And so I applied to NASA as soon as I finished up graduate school, but it was 5 years later before I was accepted. And during that time, I had the chance to work as a research engineer and write papers and talk at technical conferences, and also ended up getting a private pilot's license. And then after I was selected as an astronaut, over the next 12 years, I had the chance to fly into space 4 times. So I thought what I would do now is show you a video from one of my flights, and then we'll be able to answer some of your questions after that. So let me go ahead and share my screen here, and I'll just narrate this as we're showing it.
I'm gonna get to see a video that she took in space. How cool is that?
Okay. There, can you see it all going? Brittany, are you able to see that?
Yes, perfectly.
Okay, great. Well, this is me and my crew going out to the launch pad. Of course, this is down in Florida, Kennedy Space Center. And those are the main engines of the shuttle that run on liquid fuel that's held in that big orange tank. And this is us lifting off the launch pad. I'm the person kind of in the middle here, serving as the flight engineer during launch and landing. So I'm working with the commander and pilot during those phases of flight. The 2 white rockets that you see here on either side are filled with solid fuel, and they provide the majority of the thrust during the early part of the launch and help us get off the launch pad. About 7 million pounds of thrust. But they only burn for about the first 2 minutes of launch, and then they've used up all their fuel. So here you can see up here the solid rocket burning, and then the 3 circles are the liquid rockets of the space shuttle itself. So once all the solid fuel's used up, they separate away, and the liquid fuel gets us the rest of the way into orbit. And then over the next day and a half, we did a number of burns with our engines that operate only in space. And this was to put us on a path where we could intercept the International Space Station. So here you see me again working with the commander and pilot as we're working on this rendezvous, as we call it, where we're going to hook up to the space station. This is what we look like here. This is the space shuttle. And inside the payload bay, you can see a big piece of equipment. We called it the S0 truss, and our job was to attach it to the space station and then hook up a bunch of cables to bring it to life. And this is what the station at that time looked like from our vantage point. And here we're getting close. That's the space station coming into view as we look out the windows on the aft flight deck of the shuttle. Here it is again. That's the station up top, and then a docking mechanism in the shuttle down below. And once we made contact, we spent about 10 minutes pulling the vehicle together. Our commander was very happy with his flying there. And then we opened the hatches, and our commander met up with the commander of the International Space Station, cosmonaut Mariana Franco, as well as the other two crew members. The three of them had been in orbit for about 4 months at that time. So I think they were happy to see some new faces. We got right to work. We started transferring supplies. You can see you can do it not only in your hands, but between your knees as we're floating between the shuttle and the station itself. And then our main job, as I said, was to attach the S0 truss. So I was operating the robot arm, which is in the upper left here, and used that to grab the S0 truss and then lift it up out of the payload bay, as you see here. Now this is after sunrise, or as we've moved around to the lit part of the Earth. And this is the robotics workstation where I was controlling the robotic arm from, which is in the US laboratory of the International Space Station. Here's another view of the truss, but if you look behind it, you can actually see the Nile River and River Delta and the Gulf of Aqaba, all in the Middle Eastern region of the world. And here we're getting to the final part of attaching it. That's the space station that we see in front of us, part of it. And that kind of claw-looking thing on the right is going to grab a rod, and that's going to form the first attachment. And space station crew member Dan Bursch and I were the two that were operating the robot arm during all of this activity here. And then after we actually attached it, over the next week, as we were docked to the station, we did a series of about 4 spacewalks, all using the robotic arm as well. Actually sort of bring the truss to life. We had to hook up a whole bunch of cables. And the next views you see are from the cameras on the spacewalking crew members. And they're on their helmets, so you can see they're kind of looking down at their hands. You see here he's holding a cable tray that weighs about 200 pounds on Earth, but basically is weightless in space. And here's one of the many, many cables that they hooked up. Some of them were applying electrical power. Some of them were cables that would allow us or the ground to send computer commands and get data back. They're also attaching some of the struts to complete the structural attachment. Here's another view of the whole robotic arm, which is about 60 feet long, with a crew member on the end. And then this is what it looks like when they come back inside, and then we have a chance to get them out of their spacesuit. And here you see it's eating. This is on the shuttle side. We're hosting the space station astronauts over here and cooking up some of the space food that we have. One of my crewmates who's showing off for his 2 little boys during a video chat that he had. This is what liquid looks like when you let it loose. That's just water. It's floating in space, of course, and it forms that ball because of surface tension. And then at the end of our week, we completed all of our tasks, so it was time to close the hatch. And then we spent about a day checking out all of the shuttle systems that we needed to land on Earth. And then we started to do the undock. So once again here, I'm working with the commander and pilot. And in this case, the pilot, Steve Frick, is going to be flying the shuttle. He's going to back away from the station about 400 feet. And then we're going to wait for sunrise and then do a complete fly around of the station so we can take photographs. So here's what the station looked like. Here's sunrise. Happens really fast when you're orbiting the Earth every hour and a half. And then we started our fly around, and we needed the photographs to help with future assembly flights. So once again, the station crew is taking a picture of us. You can see our payload bay is empty now. Here's a view of the station at that time when we're about halfway around this fly around. Here we're using a laser ranging device and then some of the cameras. And then this was probably our final good view of the station, and this rectangle in the center there is the piece that we had just added. So now this is the final morning of flight. We're closing the payload bay doors and we're doing everything that we need to do to prepare for landing back on Earth. One of those things is to get into these special suits that we wear for launch and landing, which can help protect us in certain kinds of emergencies. And here you see our commander getting into his suit. And then once we've actually passed through the atmosphere, the commander takes the controls. And now this is the very final part of landing down at Kennedy Space Center in Florida. I don't know if you can read those numbers on the heads-up display, but on the left it shows we're going 290 knots, so a little over 300 miles an hour. We're passing through about 12,000 on the way to land. And we look like an airplane, but we don't actually have any engines running, so we're really a big glider. And so the tricky part is landing at the exact spot and at the exact speed that we want to in order to have a safe landing. So here you can see the very final part. The wheels are coming down and we're getting ready to land on the runway there, what we call shuttle landing facility. And there's our landing. We're still going much faster than an airplane would be going. And so we use this drag chute to help slow us down and prevent wear and tear on the tires and brakes, and have a safe landing on the runway there. And that's the end of STS-110, an 11-day flight. And I'm just gonna go for about 10 or 15 more seconds to show you what the space station looks like today, because we continued to build it after that. So you can see how large it is today. If you overlaid that on a football field, it would basically cover the football field from end zone to end zone and sideline to sideline. And it's about 1 million pounds of hardware. So I'm gonna stop sharing now. And I'll just mention that after I had the chance to go on 4 space shuttle flights, I had a variety of other jobs at Johnson Space Center in Houston, Texas, which is the home of human spaceflight. That's where all the astronauts work, people who work in mission control, engineers, scientists, medical doctors who help keep astronauts healthy in space, and many others. And I got to lead Johnson Space Center as the director for the last 5 or 6 years that I was at NASA. So I really had an amazing 30-year career at NASA, and just tried to give you a little bit of a glimpse into it, and happy to start answering some of your questions now.
Thank you so much. So pretty exciting stuff, right? I was most fascinated to see that when you were flying around with your last looks that you all weren't like seated in the chairs. You were just like in the shuttle. I don't know why that was surprising to me, but that was really surprising. So does everybody want to raise their hands if you have a question, and I will call on hands and we can go from there. In the back with your big hand. When is your birthday, Dr. Ochoa?
When is my what?
Your birthday.
Oh, when is my birthday? It's in May, and I was born in 1958.
There you go. She just had her birthday. Pretty cool. All right, let me see hands so I can call on hands. Yes, striped shirt.
What do the stars look like close up?
What do the stars look like close up? Well, the interesting thing is we're really not much closer to the stars than you are here on the surface of the Earth. We were only flying maybe about 250 miles up above, away from the Earth. but the stars are millions and trillions of miles away. So we're really not closer to them. But because we are above the Earth's atmosphere, what happens is we can see many more stars when we're on the dark side of the Earth, and we can see them much more clearly. They're not twinkling because you don't have the effects of the atmosphere. So the big difference was that the number of stars that we could see, and that we could see them more clearly, but they don't look any bigger to us because they are so far away.
Makes sense. You wanna go?
What was one of the things that you missed on Earth that you couldn't do in space?
So something you missed from Earth that you couldn't do in space.
Well, probably what it was really when I got back to Earth, I missed things that I could do in space, like float around. I think, this was only an 11-day flight, so I can't say that I missed a whole lot. Obviously, I didn't get to be with my family, but we were very busy, so it was just kind of like being on a business trip, right? The people on the space station today are up there for 6 months at a time, sometimes as long as almost a year. And I think a few things they miss are like showers. They have to just kind of take sponge baths with like washcloths that are wet. And also certain kinds of food. I mean, obviously all the food has to be pre-packaged up there, so you don't really get fresh food except when a supply ship arrives, and actually one arrived just either yesterday or the day before. There's usually a little bit of fresh food that they can eat for the next couple of days, but then it all goes back to packaged food. So people miss pizza and hamburgers and the kinds of things that you probably are pretty used to eating here on Earth.
Awesome. So we're gonna do yellow mask, red bow, and space shirt. Okay, we're gonna go in that order. So yellow mask, you're up first.
What was that little bubble?
Was the bubble in the video?
Oh, that was water. So here on Earth, if you poured water, or got it out of the faucet, it would just go to the bottom of a glass, right? But in space, because we're in a zero gravity environment, it doesn't do that. And so we just let water loose in the cabin. And because of the surface tension of the water molecules, it forms that sphere, and then it'll float around the cabin. What we would do then is just put a straw into it and then just suck it out of the air and drink it down.
Kind of like boba. You want to drink water boba in space? Okay. Red hair bow. Do you sleep in space?
Sure, absolutely. What we did is we have bags that look a little bit like sleeping bags, but they have clips on all four corners, and we would just find some space in the middle of the mid-deck of the space shuttle and clip it off. In fact, on this flight, I was kind of sleeping across the ceiling. I just found a place to put my sleeping bag there. And you really use the bag mainly, a little bit for warmth, but so you don't just float around and maybe bump into equipment while you're sleeping.
Could you hear that? So if you went back to space, what would you have done differently in the spacecraft on your if you went again?
Well, I did get to go 4 times. So I would say, just some of the things I learned on my first flight that I did a little bit differently on my second. First of all, we have a lot of different activities to do. We were doing science experiments, we were studying the Earth's atmosphere, and things have to happen at certain times. So I was wearing a watch with a timer, and on my second flight, I ended up wearing 2 watches, and they both had 2 timers. And that way I was always making sure that I knew exactly when the next thing that I had to do was, and I had all these reminders. And then I also figured out kind of which space food I liked and which what I didn't like so well. So I was able to pick a better menu the second time I went up.
Fair enough. Yeah.
How hot are the stars?
How hot are the stars?
Well, they're extremely hot. Our own sun, of course, is a star. And so other stars may look similar. They may be bigger, they may be smaller, but you know, the corona itself is actually millions of degrees, and then the surface of the sun is like thousands of degrees.
Awesome. Dionysus, did you have a question? Yeah.
How do you exercise in space?
Say that one more time.
How do you exercise?
How do you exercise in space?
Oh yeah, I actually a little bit later in the video had some video of some of the station astronauts exercising, but what we tried to do on shuttle missions is at least do a little bit of, you know, cardiovascular exercise. So we had something that looks a little bit like an exercise bike, but it doesn't have a seat and it doesn't have any handlebars. And so really our feet were clipped in, and then we could just pedal, and that would give us some exercise. What they do now on the space station is they want to make sure people are doing resistive exercise. So on Earth, that might involve lifting weights, but you can't really do that in space because the weights would be weightless. But we do have special machines that use a vacuum system that provide resistance. So it is kind of similar to using weights or doing squats or things like that. And that's very important for maintaining muscle mass and bone health, because people do lose the calcium in your bones if you are not putting weight onto your bones. So that's one way our astronauts stay healthy in space.
We probably have room for one more question, which I can, yes. What did you eat in space?
Oh, we had a lot of different kinds of food. As I mentioned, we didn't really have much in the way of fresh food. It all comes packaged. A lot of it comes freeze-dried. So you have to add water to it, either hot water or cold water, to sort of reconstitute it. And make it into something you can eat. For example, oatmeal, it would just come dried, and we would add hot water to it to be able to eat oatmeal. So we had various kinds of, you know, like chicken dishes. We had macaroni and cheese. Again, you had to add water to it, a couple soups. We did take up tortillas. So that was one kind of fresh food that we had. And they can be used in a whole variety of ways. We did have a little bit of peanut butter, so you could make a sandwich, or we had some chicken salad in a can, and you could roll that up in the tortilla and sort of have a chicken salad sandwich for lunch while you were up there. And then we had snacks, things like granola bars. We had M&Ms, but you have to eat them really carefully, because if you just open the package and let them go, they'll start flying all over the cabin. So you got to be really careful just to let one out at a time.
I think there was questions too, so we here can buy astronaut ice cream. Did you eat astronaut ice cream in space?
No, we actually don't use that in space. And if you've ever had it here on Earth, you can probably figure out why, because it crumbles really easily. And so if you bit into that in space, all those tiny, tiny little crumbs would go floating all around the cabin, and they would get in your eyes as you floated around, or you know, caught up in your nose or mouth, as well as in the equipment up there. So you don't want to be eating anything that causes any kind of crumbs. That's why we don't have bread, and why we take up tortillas instead, because they don't leave any crumbs.
Makes sense. All right, we got probably one more, and then, so if you want to ask yours, and then we'll wrap up. Go ahead, darling.
Why couldn't you just close your eyes and then?
Why couldn't you close your eyes and then eat the ice cream?
Well, if you tried to keep your eyes closed the whole time you were up there, you wouldn't be able to get your work done. You wouldn't be able to see the equipment you were working with or read the procedures. So that's not too practical.
I love that. Okay. Y'all, I think I certainly learned something. I did not know that you did not eat astronaut ice cream in space, and now I know that. So I am like, feel like I learned all kinds of new things, and now I got like knowledge for a dinner party. So I'm super happy about it. So everybody, can we give a great big thank you to Dr. Ochoa? Thank you. And can we leave her with one of our big, strong, we can do it? Can we do that? 1, 2, 3, we can do it. Thank you so much, Dr. Ochoa. I'm going to unplug you from the big screen
Okay.
and log you off, and we're going to get our kiddos off to their parents.
All right. Thank you very much. I enjoyed talking with you today.
Okay, stop recording.